I'm going to give you an idea about the osteotomy rules. Then we'll go through some clinical examples. If you want to play with the deformity, you should have 3 players: Cora, ACA, and osteotomy. So it's a match, and you need to know more about the 3 players: Cora, ACA, and osteotomy. One of them, you have no control. It looks like a fracture. You know, if you have a fracture, you cannot control it. And this is the Cora. You cannot play with the Cora because the Cora chooses its site. You have nothing about, you just have to learn about the Cora, but you cannot move the Cora out. There are 2 osteotomy types: angulation only and angulation and translation. And in this case, which is osteotomy rule number 1, we have only angulation. You see the angulation here, and normal mechanical axis. But in such a case, we have angulation and the translation. You see the medial translation. So osteotomy rule number 1, we have angulation only. Osteotomy rule number 2, we have angulation and translation. What's ACA? ACA is angulation correction axis, the axis line around which the correction is performed. The Cora is the level of intersection of the proximal and distal axes of bone. You see here we have a deformity. This is a metaphyseal deformity. This should be the Cora or the apex of the deformity. The first line represents the axis of the proximal tibia. Second, this is the first line. The second line represents the axis of the distal tibia, and they meet each other in the Cora. It's inherent property of the geometry of the angular deformity. So have no control over the Cora. Variations in the Cora around the transverse bisector line changes only the type of correction: opening, closing, or wedge, or neutral. Again, as I've told you, the Cora, the intersection of the proximal axis and the distal axis, and they meet each other in the Cora. But the Cora lies along the axis or the transverse bisector line. This is the transverse bisector line, which bisects this angle into 2 equal angles. And each point on the transverse bisector line is a Cora. This is the transverse bisector line. Again, the axis of the proximal segment, the axis of the distal segment, and the transverse bisector line, and the Coras. Osteotomy rule number 1. If you have the 3 players on the same line, the osteotomy, the Cora, and ACA, that means this is osteotomy rule number 1. And this is an example. If you do acute correction of the deformity and the internal fixation, you do your osteotomy at the same site of the apex of the deformity, and you can put a plate, or you can put external fixation. Osteotomy rule number 2, the ACA passes through the Cora. So the ACA and the Cora are on the same line, but the osteotomy are not on the same line. So the osteotomy does not pass through this point. The bone ends will angulate and translate. However, the proximal and distal axis lines will realign fully when the magnitude of correction equals the magnitude of angulation. And this is an example of the osteotomy rule number 2. We have a physeal injury, and you look to the valgus and the recurvator. This is the AP and lateral. The deformity lies in the joint or in the physis, but we don't want to do an osteotomy through the physis or the joint. So we do our osteotomy, here. But this is the deformity lies. So we should have a displacement to correct the mechanical axis. So this type of the displacement, you can correct the mechanical axis. Osteotomy rule number 3, the ACA does not pass through the cora, so they are not on the same line, the 3 elements, the ACA and cora and osteotomy. And this is a clinical example. This is malunion of a fracture. If you want to apply rule number 1, you do your osteotomy exactly at the same time, at the same place of the fracture. Because the site of the fracture is the site of the cora. So this is osteotomy rule number 1. But if you do your osteotomy not exactly at the site of the cora, this is osteotomy rule number 2. So in malunion, you can apply osteotomy rule number 1 or osteotomy rule number 2. And this is an example of osteotomy rule number 1. This is the deformity, and this is the apex of the deformity. We did the osteotomy exactly at the malunion site, and you have an open wedge, and this is osteotomy rule number 1. We have alignment of the mechanical axis, a normal mechanical axis. This is osteotomy rule number 2. We have malunited fracture neck femur with coxavara, as you see here. This is the axis of the neck of the femur, the proximal femur, the axis of the joint, and you have about 80 degrees. We want to correct the joint. We did osteotomy, and we have about 130 degrees, but we did medial displacement. Because here is the cora, but the osteotomy is not exactly at the site of the cora. That's why we should have displacement, and this is osteotomy rule number 2. But at the end, we should have alignment of the mechanical axis. Another exercise, we have a case of malunion. This is malunion. And we have this deformity, C-shaped deformity. We have 2 options. Either we do an osteotomy at exactly the same site of the fracture, or to do osteotomy and deformity correction. If you do an anatomical restoration and do osteotomy here, it's a heroic operation, and the skin is adherent, and you are going to have significant bleeding. So we prefer osteotomy and deformity correction. You see this is the proximal segment, and this is the distal segment. And you see the lateral side. We have translation also and angulation. So if you draw the axes, the proximal axis and the distal axis, and this is the normal side, and this is the lateral side. The guy is working as a bodybuilder. So we draw the mechanical axis of the proximal segment and the axis of the distal segment. You are going to meet outside the bone. So we draw the 3rd line of this axis of the middle segment. So we are going to have 2 cores, upper core and second core. And we do 2 osteotomies, one in the upper bone and another osteotomy in the distal part. So we do an osteotomy up there, another osteotomy in the second cores. Then we do gradual correction of the deformity and lengthening, both of them, as you see here. And also translation. Look to the mechanical axis. You see, this is the site of the non-union. We ignored the site of the non-union because the skin is adherent, and it's very difficult to do an osteotomy here and do an anatomical reduction. But look to the mechanical axis. It's almost perfect mechanical axis. And look to the lateral again, and normal mechanical axis on both sides. So it's very helpful to know both rule number 1 and rule number 2 of the osteotomy. And there are many clinical considerations. So if you think about the osteotomy level, you have to think about the geometry of the deformity. type of fixation, proximity of osteotomy to the physis, joints, or ligamentotendinous insertions, soft tissue coverage if the skin is adherent, infection, bone quality, and other clinical factors. Another example of a physial injury, look to the physial injury and shortening. If you want to do osteotomy, we're going to do it through the joint, which is almost impossible. So we do the osteotomy in the metaphysis, and we do displacement. See the displacement and lengthening. So osteotomy, angulation, and displacement. And this is osteotomy rule number 2. So you can correct the mechanical axis, as you see here, by applying osteotomy rule number 2. So in conclusion, if you want to deal with the deformity, you have 3 players: the cora, ACA, and osteotomy. We have no control on the cora, but we can decide the ACA and the osteotomy. We have 3 osteotomy rules. We almost use the first rule as we do the osteotomy at the same site of the cora and ACA. Osteotomy rule number 2, we use it only. There are very few indications for osteotomy rule number 3. That's it.